Making a video, I think. Anyway, sort of a response to an idiot. That's all there are, these idiots, apparently. So he made some sort of video called Straight Outta Mendham. I'll leave a link below. I won't let him post links to it on my videos. Absolute piece of garbage. Can't even listen to it. Give you a sample. I mean, he goes to the trouble to do his humorism thing. He's being a humorist, and it's just a piece of crap.
But before we begin, you have to acknowledge that you have a problem.
I mean, who can computer voices with static? Oh, just brilliant. So just type the text in the description, please, because I can't even use I tried to read the transcript, but the transcript obviously is broken because of all the static. So he's apparently, again, wants to argue interferometers and relativity arguments. But he can't do it in any kind of civil way. He has to shit on every argument he makes. He's such a great scientist, he has to smear shit on every single point he makes. Like somehow somebody needs to point out how Newton was a crazy Christian fuck before they actually make their argument or something. Like that's what a professional scientist wastes their time with, is personal attacks. And they do it as a coward. I mean, here he is hiding his little tiny penis from view while he ridicules other people's penises. I mean, he's just such a coward. So if you're going to bother doing your humorism thing, humorists really can't get away with that. They can't get away with, I'm a fat guy, I'm going to hide behind the curtain and then make a bunch of fat jokes. They really can't get away with that shit, okay? I mean, you want to play, you have to play like a man, okay? Grow some nuts. If this is all you got is ridicule, and help you open yourself to the same bullshit, the same waste of your time. You asshole. I mean, really, you seem to have a huge passion to prove me wrong or prove me incorrect. Well, why can't you just make the logical, sensible argument demonstrating where I'm wrong? So this appears to be the same asshole who argued that if you make the slit small enough, there's no diffraction. Okay, I mean, stuff that's just easily dismissed as absolute nonsense. I don't think there's a physicist on Earth who believes that. I haven't seen one. So just a nonsense argument. But he thinks he's, got something that needs to be addressed, but he can't seem to put it in some sort of civil form. He's so, in his defense of science, he has to just litter it with a bunch of idiotic personal insults that just serve absolutely no purpose at all, while he's hiding as an anonymous troll. I mean, it's just so bad. So anyway, it'd be nice if somebody has any sympathy with these kind of assholes and they can actually have enough discipline where they can actually make a logically formed argument pointing out where I've made some error. That would be swell, but these people aren't capable. Alright, so enough of this. I haven't finished watching this piece of crap either. So anyway, I don't know if it's worth going into the comments on this video, because it'd probably just be a distraction. Yeah, so we'll just stick to the interferometer subject. But really. Alright, so, I've already pointed out that they really haven't gone through the physics of this experiment. Physicists don't bother with that. They just assume because they get a pattern out, it looks like, and they just do their it looks like thing, and that's the end of it. There's no real analysis for how it's really possible that it's happening, or how consistent it is with their theory of how it happens. Again, let's understand the single slit somehow has to create two different waves that interfere with each other and end up with a photon landing in a specific location. How does that fit into this experiment? Where do the photons turn into two photons, and where do they do this interference and all of that? And they have no explanation. There's just nothing. No clue how this thing is supposed to have worked. So I've sort of argued that it's an instrument that's perfectly capable of doing some measurements, because it does have a feature where the light that's going through the experiment is diverging. So if you have something diverging, you can use that as a ruler, right? I mean, it's kind of obvious. If it starts at a little tiny point and it gets wider at another point, that's essentially a ruler, and you can measure things with that ruler. So yes, it is capable of doing that. Whether it's capable of doing it to the wavelength of a photon, that's where I would argue I think they're misunderstanding the precision of the instrument. All right, so there's just so many details. So I guess the first thing we'll go is there's two ways to see the light clock in a spaceship, for example. So the idea of the light clock is that you have a moving spaceship going in a direction, and you basically just send light going back and forth, okay, between two mirrors. And this is an Einstein thought experiment. Obviously, we can't do these things, but it's a thought experiment. And the idea would be is that as you have velocity in a direction, their theory is that the light somehow knows how fast this stuff is going, and the light bends in the direction of the motion, so it still can hit the mirror. And yet the light will be traveling, you can sort of see, a longer distance. You know, this distance much shorter than this distance to the mirror. So it creates all kinds of little paradoxes, in my opinion. And I would argue that no, the photons will do exactly what they're supposed to do, which is they'll move perpendicular and the spaceship will move away. And so what you will see is that the photons end up hitting a wall over here, but they move perfectly straight to get there. You know, they never did a curved line and they didn't shoot any direction. They went perfectly straight and the spaceship moved away, and in the time it took them to get across it, and that's where they ended up. So then the forward-back one gets to sort of the redshift argument. So if you shoot the light forward to a mirror and then the light's reflecting back and you're moving, obviously it's going to take the light a lot longer to get to the front of the ship, because the ship's going the same, it's going in the same direction as the photon. So it's competing with it in terms of moving as the photon is moving. So it's taking some of the speed off the light. And obviously the return trip might be twice as fast, depending on how fast you're going, or at least half the amount of time. If you're going half the speed of light, it'll be half as much time to get to the back of the ship. So the two distances would be timed very differently. So I've tried to explain to probably this person or somebody similar, that these redshift arguments with moving objects aren't as simple as things just bouncing off of surfaces. So I did think of an analogy of sorts. I don't know if illustrating it's going to do much good, but I've used this idea of fish before. Fish, a school of fish, to explain what matter really is. It's not as simple as a solid object. The matter itself is composed of elements, and the elements actually do possess momentum. So if a school of fish is moving in a direction, it means that most of the fish are moving in that direction. You can kind of understand that logically, right? If most of the fish are swimming this way, then the school isn't going to go that way. And the idea of this whole energy thing, as I've pointed out, is that the little bit has to hit something that will release energy that is reflecting. So we're talking about a reflection here. So if this was a mirror, you can sort of understand the mirror's moving. Well, the little bit it's going to take it a while to find a fish swimming in the right direction to release a reflection. It won't get a reflection from a fish going the same way. As I pointed out, that just means you're just going to hit it, and the fish is going to release a piece of energy going in the same direction as the piece that hit it, which will equal nothing. It'll be a non-event. So the real event, this is the right way, the real event has to be a fish that's going the wrong way. And so obviously the faster this school is going in this direction, the fewer and fewer fish that are going to be going the right way for you to hit. So this object wouldn't bounce right off this surface, because it's the first fish it hits probably isn't going to be a fish going the right way. And the second fish probably ain't going to be a fish going the right way. And the third might not, and the fourth. So it's going to spend a lot more time finding that fish. So that means, in a sense, it's going to go into the substance before there's a reflection. So it's going to consume a whole bunch of time searching for that fish before it reflects. And they don't account for this extra time spent interacting with the matter. Now the opposite argument would be, obviously, if the school of fish is moving towards you and most of the fish are heading right for you, theoretically, just draw a third fish there. Okay, so they're heading right for the bit. Then you're going to hit a fish the first shot, and you're going to get your reflection right away. And you're not going to waste any time. Minus time. No time wasted. 0. T equals 0 time spent inside the school of fish looking for a fish. So you can sort of understand, if you put these things in the right order, that these things do change the timing of the experiment, and that timing difference is all the difference. Now, even in this sound argument, you can sort of, like even a hose, and you're talking about whether one person moves away from the hose or the person holding the hose moves away from you. It's an obvious change in timing. Now, although the shift will be exactly the same, which you'll perceive, when you perceive it will change. So if the guy with the hose moves away from you, okay, you're going to get the water the water ejector is moving away, which means some of the water has to travel the longer distance, the longer amount of time. So the point is that although you'll hear the same stuff, the same number of bits will go from one person to the other. The same number of drops will fly from one person to the other person, no matter which way you do it. When the drops hit you will change depending on who's moving. Whether you're moving away or he's moving away will change when the first and last drop hits you, kind of a thing. And that's because of the frequency change. So you could sort of see that in that old animation the other person provided, where the little bits, there was a whole bunch of the ones at a higher frequency stuck that hadn't reached the other dot before the other dot had already done the 16. It already experienced the whole experiment when there was a bunch of the sound still in the field in the other thing. So there's a delay in how long it takes when you're redshifting. So that sort of makes sense. But anyway, so that's a little bit of an obscure argument, but there's lots of subtleties, and they don't pay any attention to them. So there's no subtlety at all here in this physics. It's all just, it seems like, it looks like, and they don't care about a detail. And that's why their experiments don't have any consistency. The single slit isn't consistent math with the double slit. The double slit's creating a pattern they don't even bother to explain, a secondary pattern. And so there's just no analysis. And you'll see no analysis, I can't find it on the internet, no analysis of a blow-by-blow explanation of what happens to a photon as it travels through an interferometer. There's just absolutely nothing. No one says, well, look, it starts here, A, 1, and then the photon moves, and it's going to hit this impediment. So I'm going to do some of that. And some of it, I have an explanation for what's happening. I know certain things, okay? Certain things are theoretically solid, like diffraction gradients, like what happens to light when it passes through a little slit. We know this one, okay? We know what's going to happen. We might not have a similar explanation of why it's going to happen, but we know the light's going to be diffracted. We know it's going to be diverging light that exits. All right, so the other thing to understand about Michelson-Morley was that they were moving the whole experiment, which is another tricky business. So you're starting off with the experiment moving this way, and then you turn the whole experiment perpendicularly, which is very difficult. The whole thing had to be in mercury to make sure there was no vibrations and it could turn easy. I mean, very complex. So not only is it a experiment they haven't really done any detail on figuring out how it works, it's an experiment that has lots of room for error. Not that I care. Again, I don't consider Michelson-Morley a relevant, meaningful experiment. And I wouldn't care less what the results were either way. Because either way, I don't think they're saying anything about the real world. But anyway, so let's play with this. Alright, so we'll probably take all the extra mirrors out because, you know, the 18 reflections, because that just complicates things. So the idea is the photon leaves the source. And let's say in this particular case, the whole experiment is presumed to be moving this way with the rotation of the Earth. So the photon is moving with the rotation of the Earth. See, this just getting into this kind of crap, as I pointed out in the other diagram. It just gets complicated because then you have to take into account the fact that, oh, okay, so the photon's moving and the thing it's hitting is moving, which again means there's less fish to hit, so it's going to spend more time interacting inside the mirror, you know, all that kind of crap. But we'll try to avoid as much of that as possible and just get to the basics here. So what we have is a piece of glass, and then we have the mirrored surface. So I'll draw that as a jagged line, the half silvered backing. Now, as I've demonstrated, you don't really need to use a half silver to get a pretty strong reflection off just a plain piece of glass. Now, theoretically, it's supposed to only be 8% off the two, 4% off one surface, 4% off the secondary surface. But I would argue it's clearly stronger than that at a 45-degree angle. The amount of light you get is much stronger. So whether it's 30, 70, I can't say, but it sure looks like that. But part of the reason why it might look that way, no, not in the case of the plain glass, so I won't bother saying that. Alright, so the idea is the photon's heading for this thing, even though I don't have it lined up perfectly right. Okay, just forget about this guy. So this is the guy moving. And he's going to hit this half silvered. And the idea would be is that there's, because of this half silvering, there'd be a 50-50 chance of the photon going this way. Now obviously there's a problem right away because we know there's a 4% chance of reflection off this surface. If the light was coming straight down on this first surface, there'd be a 4% chance of reflection. And as you increase this angle, you increase the percentage. So we already know that just off the surface of the glass, this percentage might be, there might be 10% just right off the surface of the glass. So this can't be a 50-50 mirror, because that wouldn't account for the 10% or more that reflected off the surface already. So that's your first problem. Like I said, we're already in trouble. We're already in trouble because we have more than one surface and one more material, and so we're already in big trouble. So we already have 10% of the light, at least, maybe 15%, that reflected right off this first piece of glass. And we haven't even got to the second surface yet, the second piece of glass, the second surface of glass, let alone to the half silvered mirror. So already we're, well, what do you mean? Does somehow this top surface doesn't reflect light anymore because you put a mirror? A mirror doesn't reflect light off the surface of the glass? Well, of course it does at a 45-degree angle. So obviously the half silvering can't be half silvering. So let's say you just test it and says, okay, it works 50-50. I'm getting 50-50 out, so I'll assume this mirror is 50-50. But it obviously can't be 50-50 if you're getting 50-50 out, because it wouldn't make any sense. So it's some other percentage, a much lower percentage. That is, it's more gaps than it is silver. But anyway, at any rate, we'll just say, okay, so we're already in trouble. We haven't even barely started the experiment, and we've already got a paradox or a circumstance that doesn't make any sense. Obviously, it can't be 50-50 silvering because there's a reflection off the first surface of the glass, so that doesn't make any sense. So the second surface now has the attached silvering, so that does change things, okay, in terms of the reflective index and how likely you are to have reflections, but it's also got the same deal, same percentages in terms of there's a reflective index off the second surface. And the second surface, I believe, depending on the density of the material, which would be where the silvering isn't. Okay, so this is the complexity, right? Where the silvering is, the thing you're reflecting off has a higher reflective index, and where the gaps are, we presumed it to be air, that has a lower index, which means that these reflections can be out of phase. There'll be a phase shift when you go from higher to lower or from lower to higher. You'll have a phase shift in the light. So we're already creating phase shifts now, changes in the phase of the light. I mean, this conversation is sort of for people to know what that is already. I don't want to have to explain all this stuff, but the idea would be is that the photons would be coming, I would argue, as corpuscles, and a phase shift would mean that they're now, you know, a half phase off, you know, that they're not aligned up anymore. So you know, we haven't really got to the real complication created by the silvering of the mirror, and we're in trouble again because now we have to account for phase shifts, because the light that actually is transmitted through, so the light that gets through these holes, so understand that the half silvering or the 3/4 silvering or whatever kind of silvering is basically going to be an idea like this. It's going to create a bunch of gaps, and those gaps are going to be essentially single slits, and they're going to make the light diverge. And the smaller those little holes are, those gaps are, the greater the divergence. And so we don't really get a conversation about how small they are, but obviously you can sort of imagine that in the real world this experiment's, you know, shooting things through mirrors that are probably only this big, and that the holes aren't gigantic holes, so they're probably very, very small, like spray paint, you know, little dots of spray paint with gaps between them, you know, very, very small openings which create very, very wide divergences. So here's the experiment. So we're the first beam, okay, one part of it reflected off the top surface, one part of it may have a phase shift, okay, and it reflected off the second surface, and then still there's the beam that actually hits the part that's half silvered, and it's certainly going to go this way, and it may or may not have a phase shift. So which one has a phase shift, I'm not sure, you know, but there is a phase shift issue involved. All right, then they have the light. So let's just say this ends up being 50% of the photons, which obviously seems pretty unlikely when you think about it, but okay, let's just go with that. It clearly is impossible if this is actually 50-50 silver. So if this is actually 50-50 silver, I would argue it's impossible that this would be 50% of the light, just from the fact that you cannot deny the surface of the glass will reflect a percentage of the light. So it has to be at least 54%. Anyway, all right, and then the other beam is going to now go through these openings. Okay, so the one beam theoretically reflects either off the glass surface or it reflects off the mirror, and it goes this way. No cause for it to be diverging because it didn't go through any small holes. So this light is not spreading as it travels. Now the other 50% is going through the little openings. Now we know those little openings are single slit experiments. We know that it's a fact that the smaller the opening, the more the divergence. There's no point where you can make a small opening and now the light doesn't get bent anymore, and we don't have to worry about Heisenberg or any of that nonsense. We know their theory says the smaller the opening, the more likely you are to get scatter, you know, to get photons going in very eccentric directions. So this beam that gets through is spreading. So it will be spreading through its entire journey, and its journey will include a mirror at this other side, and then it'll bounce through a whole bunch of other mirrors, okay, you know, 18 of them, and then bounce all the way back and then start heading back this way. Now the trick of the experiment, the problem, one of the problems with the experiment, one of the many problems. All right, so this beam is going to diverge through this entire distance. Now the other beam is also going to go through a whole set of mirrors. Okay, it's going to be hitting this mirror, a mirror, by the way, that's moving with the Earth. Okay, so it's moving into the beam that now is going perpendicular, and we presumably perpendicular, but as pointed out, this mirror is also moving with the Earth. So is this beam really perpendicular, or is it really coming off at some weird angle? Like if I actually could get this experiment to go half the speed of light, would it mean that this light wouldn't be leaving this mirror perpendicularly, that it would leave in this direction, you know, much forward of perpendicular? So these are all questions that just create all these kind of paradoxical circumstances, because if you pick one, it doesn't work, and if you pick the other choice, it doesn't work. It doesn't make sense. It breaks some law of physics. The laws of physics will not be the same everywhere if you pick either one of those choices for this circumstance, presuming you know, that you're going to have momentum issues with things moving into other things, and where our assumption is that creates more velocity or more momentum or power when things are moving into each other. But the truth is the photons can't ever hit each other any faster than the speed of light. So we're back to the fish argument. The fish heading right for you can only go the speed of light, and your fish can only go the speed of light. That's the strongest impact that can ever happen. Nothing can ever move a little more than the speed of light because it has some extra momentum from some magical place. Can't happen. And the real trick is the thing moving the speed of light is attached to something that's moving some other direction. So all you're really changing is how likely you are to hit it. If it's moving away from you, you're less likely to hit it. But when you do hit it, it'll be the speed of light. It'll be speed of light on speed of light. When you finally find a fish going the right way, it's not going to have extra power. All right, anyway. All right, so this beam is diverging. That is, it's spreading. And the trick is, see, to compensate for the fact that in the experiment, one beam of light goes through the thickness of the glass, all right, an extra time. And so they put a dummy piece of glass here to compensate for that. See, when this beam comes back, so it goes through the experiment, bounces off all this stuff, and they're not going to get the beam that goes back through the little holes again. They're going to collect the beam that reflects off the mirror. Now remember, the silvering's on the outside, so this beam isn't ever going to go through this piece of glass again, where this beam goes through the glass both times. So they put a dummy piece of glass in here. Now the problem with that is, on both trips, it's going to get messy, because as what's going to happen inside of glass is when you put light into a glass surface at an angle, it can internally reflect. So this is going to cause internal reflections because this light is diverging, so it's coming in at angles, so it's going to internally reflect, and that means it could hit 2 or 3 or 4 or 5 or 6 surfaces before it finally ejects. So there's just a probability on each reflection of it being transmitted through the glass. So on each impact there's a whatever 10% chance, 4%, 7, whatever, 10% chance, 10% chance, 10% chance. So it's like flipping coins, and you could realize that you could get lucky and get a heads on the first flip, or it could take you 7 or 10 flips before you get a heads. So where the photon exactly comes out is going to be dependent on how many reflections it had inside the glass. And so that's going to be happening on both trips. It's not even going to be happening on the trip into the first mirror, but it's going to be happening when it comes back through here again, and it's going to even have a higher angle of divergence. So it's spent more time diverging, so the angle is going to be higher, and there's going to be even more likelihood of internal reflections in that dummy piece of glass. All right, and then the photon's going to come back to the silver, and the silver's just the silver, so at least that's a pure reflection. So whatever happened here, whatever's coming out of this piece of glass, when the light's photons are finally coming back through here, at least they'll be accurately reflected off the silver and head back this way. So you have beam 1 that is diverged through the whole thing. So it's a beam that's diverged a lot, because it's diverged through 18 meters worth of mirrors. And so it's been spreading for a long time. Now the other beam, okay, it's not only hitting a mirror that's moving, which means that it's moving in this direction, so it's going to hit a fish easy, going this way anyway. So it's going to be a quick reflection off that mirror, but the other mirror is going to be moving the opposite, so it's going to be moving away, so it's going to have to go deeper into that mirror. But anyway, it's going to do all this reflecting, and then it's going to come back, and then that beam, okay, that now hasn't been diverging, So the whole trip, it hasn't diverged at all. Now it's going to go through the silvered mirror. Now it's at the very last leg is going to start diverging. So it's going to have a little tiny bit of divergence as it goes through the silver. Now what I would argue is if you do this experiment, you don't even need this leg at all. You can just cut it off. Okay, don't even bother looking at it. And all you have to do is reflect the light off a mirror here and look at what comes through this way. So if you look at the pattern that comes back towards the laser, it'll have this perfect pattern on it. Perfect interference pattern. And there was no place for the photons to interfere with each other. Okay, there's no interference happening if you just use one beam, bounce it off a mirror, go back through the beam splitter again and look at this pattern. And what it's really doing is it's going through the half silvering, but more importantly it's going into the piece of glass, and the glass is causing the internal reflections. And the internal reflections are what you're really seeing. These bands are being made out of is where the light was internally reflected. Alright, so the point is that there's nothing here where you say, okay, the photon goes in, it turns into two. So the question they don't answer, the little snarkies, you know, if I directly ask them, where does this photon turn into a wave function? So does it turn into two photons here? Because that's the theory, right? In the single slit experiment, there's two photons. In the double slit experiment, there's two photons. One photon goes in, two photons interact, two wavecons, two whatever the hell they are. Well, where does that happen in this experiment? How is it caused? Because obviously the first piece of glass isn't going to sit there and make that happen to a photon. So we know that that first photon isn't going to turn into two photons. So where do they turn into two wave functions? How do the wave functions go through all the mirrors and the wave functions come back through? When are these things photons and when are they wave functions? Because only wave functions are supposed to be doing the interfering. And if you're conceding that no, it's just regular photons, so if you did the interferometer with a single photon at a time, do they think the experiment would work? Because it seems pretty clear that they're relying on more than one photon. They're relying on these photons somehow interfering with the photons that went this way, and that somehow they interfere in this space here. So another thing to understand is Michelson-Morley didn't receive this pattern as like look at it on a wall or something. They used a telescope actually to just look at the very center dot. So they weren't really looking at this ringed pattern. They were just watching this dot go blink on and off. And then again they turn the whole experiment, which doesn't seem very practical. Doesn't seem very possible to do when you're measuring something as fine as the wavelength of a photon. So anyway, so these are all these unanswered questions. So they talk so arrogantly. They say they're so dismissive. They say you can't possibly be right. Yet their theory is uncognizable. I can't make any sense out of their theory. Again, these are established facts. The fact that the surface of the mirror will reflect light is a fact. The fact that the second surface will reflect light is a fact. That's stuff professional optics people will tell you. That's how it works. The surface transitions is where the light is getting refracted or deflected or reflected. It's not happening throughout the piece of glass. It either happens on the surface or it happens on the other surface. It's always the transition surfaces, and there's strict rules about how those transitions work. That is, if you're going from air to the glass, you won't have a phase shift. But when you're going from the glass to the air, you will have a phase shift. I mean, these are just facts. And so these people are ridiculing me because I'm just pointing out that there's a whole bunch of established facts, and this experiment is inconsistent with half of them. You can't make any sense out of what they say the experiment is doing if you pay any attention to the facts. The fact that a half-silver mirror has to create two different beams. They can't be equal beams anymore. They're not only not in phase, okay, they're moving, they're spreading, which means they're taking a longer path. So the whole point of the divergence is that's another way of creating a phase shift. If the light has to travel a longer distance to get somewhere, all right, that's going to create a change in its phase. That's the same geometry as the double slit experiments explains to you. As you move in a direction this way, as you create bigger angles, the phase, okay, of the light isn't going to be in the same position when it reaches the target, and you're going to have a phase shift. So divergence creates another phase shift in the light. So you have like at least 3 ways to affect the phase of the light in the experiment itself before you even get to any kind of notion of interference. And so again, it's like, you know, this as I've said before, this whole optics stuff is a whole area of physics that's clearly not as interesting to people as it should be, because there's a lot of physics happening. A lot of physics is happening to photons going through transmission mediums, what we consider transparent substances. It's just not as simple as, oh, it just goes through. It doesn't just go through, it's transmitted through. And it's transmitted through very accurately, or, as we see with water and other things, the light is changed, it's bent, its path is different. And there's real rules about how that happens. And again, their explanation of how this interferometer works doesn't explain any of it, isn't consistent with any of the rules. There's none. As stated, if somebody can show me a step-by-step diagram of how a photon navigates this experiment, show me a physicist explaining what would happen if you use single photons and what would happen if you use many photons. Show me. Again, why can't they do the experiment with single photons and just demonstrate that, yes, there's a wave function somewhere in here? Because they haven't done it. All right. So I don't know how much, like I said, you can get into a ton of minutiae and details. So he thinks he's got me on some kind of, like, I've made some critical error, because I basically just pointed out that this moving ball is a lot more complicated than what they're saying. You can't just say there's a table and I'm bouncing the ball off a table. It's just wrong to say that that's how photons interact with the environment they're interacting with. They're interacting with electrons and protons, and those electrons and protons have their own momentum, and if they're moving away from something, they're going to react differently than if they're moving towards something. These are all the rules you have to account for. It's physics, okay? These grammar school, childish, block A, B, C, D, E, F, G blocks. These block diagrams are not going to build the Empire State Building, okay? You can't do it out of little wooden blocks. You have to be a little more sophisticated than that. You have to deal with the real mechanical physics that you know to exist. Protons are real things, electrons are real things, the tension in atoms are real things, the pressure, their movement, their momentum, and they have to account for how that functions. They can't just pretend the mirror just reflects. It's more complicated than that. And again, I get insulted by these turds. I get personally insulted because I point out how their theory doesn't make any sense. They don't have any details. They don't have an explanation. And they're just going, it looks like. And they just keep doing that. And that's not good science. So yeah, that's enough, I think. Oh yeah, I don't need the mouse. So you can, yeah, the drawing's a little bit, not in there. Yeah, lots of stuff happening. You saw it made, so you should say, I still get it. I know it's in there. Anyway, till the next time, and such.